if we're looking at using natural gas as an energy source for the country to, say, generate electricity, natural gas is a great source from a climate perspective because it has less carbon, is more energy per unit carbon, so its carbon intensity is less. And so here are some data, again, for the United States. It's showing carbon emissions or carbon dioxide emissions from average natural gas and an average coal-fired power plant. And you can see that the natural gas-fired power plant has half the amount of carbon dioxide emissions. So if we're interested in climate change and we want to reduce our carbon dioxide emissions to try to address climate change, shifting to natural gas is a potential, at least a step towards a solution to try to address that issue. So the primary component of natural gas is methane. And so it's a molecule with carbon and 4 hydrogen atoms. It's a tetrahedral looking structure. And that's the primary component of natural gas. So about 90% of natural gas is methane. And the concern from a climate perspective is that when we're transporting natural gas, we're bringing it out of the ground, we're transporting it in pipelines, some of that natural gas leaks into the atmosphere. And through engineered vents, but also just through cracks in pipes and these sorts of things. And so some of it's escaping to the atmosphere. And so we worry about that from a climate perspective because methane molecules are very effective greenhouse gases. And the concern with climate change is we're adding these greenhouse gases to the atmosphere, primarily carbon dioxide, but it turns out that methane is even more potent than carbon dioxide. It has to do with the structure of the bonds of the molecules. So right now the Earth cools itself by radiating energy back into space. And some of that radiation is captured like it is in a greenhouse. You go in a greenhouse, the sun shines in, and it gets hot. And that's because the glass of the greenhouse is capturing the radiation and keeping it in the greenhouse and warming the air. The same thing happens in the atmosphere. So the atmosphere absorbs a lot of that infrared radiation and warms the atmosphere. It warms it from it should be without the atmosphere, it would be minus 20 degrees C, frozen water and all that, whereas it warms up to an average temperature of about 15 degrees C. So it's a big effect on our climate. So the issue is there's a window, absorption window in the atmosphere, this narrow window where some of the radiation escapes back into space. And that's how the Earth cools itself. And so there's this window, and the issue is greenhouse gases are essentially closing that window as we add greenhouse gases to the atmosphere. And so CO2 absorbs infrared radiation at the sort of edges of the window. So every CO2 molecule we add isn't as effective because we're already absorbing a lot of that infrared radiation right now. So the thing about methane is because of its bond structure, the way a molecule absorbs infrared radiation is basically by wiggling, right? So a photon will hit the molecule and the bonds will absorb that and wiggle, essentially, is the way I think about it. It has a very different bond structure when you look at the two molecules. And essentially, the bond structure of methane means that it absorbs infrared radiation right in the middle of the window. So nothing else is interfering. And so that's every individual molecule has a much more bigger impact than every individual sort of CO2 molecule. And so that's the concern. And what that means is just a little bit of leakage, right? Since it's 80 times worse, on the order of 80 times worse, just a little bit of leakage can offset a lot of benefit, a reduction at the point of use.